Okay, so we got 3 3/13 by breaking up
This, I think it was.
the long bit into units of 2, 2, 1.
Yep.
2 longs and a medium, 2 longs, 2 longs, a medium, 2 longs and a medium, and then we had one medium left over.
Yeah.
Okay. We got the 3 1/7 by doing this approximation with these. Okay, and let's see, where does 22, does it line up?
It lines up right about here.
Okay. Does it seem like 22 is too long or too short?
It seems like
Yeah, I'm gonna get these lined up here, exactly.
it looks like it's just a little bit too short. A little too short.
Oh, that's interesting. So 3.142 is just a little bit too short, okay? That's interesting.
And then, wait, but wasn't this was the 3 point, was this the 3.2 or the 3.17?
Oh, okay, so we've forgotten which approximation was which. With the shorts, what did we do?
Well, our little long medium was 7.
Okay, is 7 too long or too short?
It's too long.
Ah, so our we've got a little bit of an error there, it's too long. And up there, it's 22 is a little bit short. So our denominator is a little bit too low, and our numerator is a little bit too low. Denominator is a little bit too big, just a little bit too big. So when you divide by a bigger number, what happens to your fraction?
It's gonna get smaller.
Okay, so we start thinking that 3.14 is a little bit too small, right?
No, but how much too small?
Well, how much too small? Okay, so now we're starting to see one of those approximations was a little bit too small. Now let's look at it a third way. I'm gonna say the thing that's common about our two original pieces,
Yeah.
you just move the shorts away, is they are made up of longs and mediums.
Yeah.
So how many longs and mediums in the first bit?
There's 2 longs and 1 medium.
Okay, what about in the second bit? How many longs are there?
1, 2, 3, 4, 5, 6 longs.
6 longs.
And then 1, 2, 3, 4 medium.
6 and 4.
And here's 2 and 1, 6 and 4.
2 and 1, 6 and 4.
Well, we said those were related to the pentagon.
Ah, let's bring our pentagon back.
So we might, I think, what we did for the pentagon to find the new size is we
Here,
used
can you just kind of sweep everything out of the way here?
that right there.
Okay.
So here it is.
Inside this pentagon last week, we started seeing a pattern in the number of longs and
It
mediums
was
as well.
the Fibonacci.
It was the Fibonacci series.
Could be. Maybe the Fibonacci series comes into play here.
Maybe it does come into play here. Do you remember, or do you know, have you ever heard about the ratio of the numbers in the Fibonacci series?
I don't think.
No.
1, 1, 2, 3, 5, 8. Those ratios start approaching something called the golden ratio. Have you ever heard of that before?
Yeah.
Do you know what the golden ratio is?
I don't think so. Is it is it 1 to the square root of 3 or something?
It's 1 plus the square root of 5 divided by 2.
I wonder why they call it the golden ratio.
Well, we can talk about that some other time. 1 plus the square root of 5 divided by 2 at least has a square root of 5 in it, right?
Yeah.
We saw the Fibonacci numbers in here last week. So does that lead you to think we might see the Fibonacci numbers in this project today?
Yeah. We might, but the golden ratio could be the ratio between the mediums and the longs.
Oh, it might be the ratio between the mediums and the longs. That sure would be interesting.
Yeah.
If the mediums and longs were in the golden ratio, aha, what would that mean?
It would mean. Well, which one of our
choices would it be?
Well, what did we went from 2 to 1 to 1, 2, 3, 4, 5, 6, and,
1, 2, 3, 4.
okay. Let's work this out on a piece of paper. If the longs to mediums were the golden ratio, what would we get here? That's a very interesting question. Are you ready?
Yeah.
All right, let's do that. I like that idea.